Hello, algebra students. Mr. Lawrence here, and we're going to explore three more types of patterns. Not three more types, but some special types. Those of you that came in on Monday to the algebra party, Kristen and Dan, you're already going to know how to do this, so it's going to feel pretty special. Anyway, here's a sequence of numbers, 5, 17, 37, etc. And so I'm going to put them in my table. There's x term, and then f of x. Remember, x is the input, f of x is the output. And 2, 3, 4, 5. I'm looking for the nth term. And I got what? 5, 17, 37, 65, and 101. All right, so I go finding the first differences. Plus 12, plus 20, 65, 28, I think, right? Yeah, and then this one here is 36. Yeah. Okay, and then I go finding the second differences, and that looks like it's plus 8, and plus 8. Now, the second differences match, right? Which forces it to be quadratic. But if you remember in a video a couple days ago, I mentioned that, we had plus 2, plus 2, plus 2, and then we had n squared. And remember, I pointed out that it was a 1n squared. And I said that this number is half of that. Well, since this is a plus 8, the n squared is going to be 4n squared. Yeah, we're going to take half of the second difference and make it 4n squared. I'm going to change the color on that. Okay, so it's going to be 4n squared. So now I'm going to do my comparison line. And I'm going to put Dan Michael likes to do it like this, okay, under each one, and that's fine. Helps him get it right, so I think that's what he should do. If you don't need to do that, then that's okay. Oops, that should be squared, sorry. And then 4 times 5 squared. So 5 squared is 25, times 4 is 100. 4 squared is 16, 16 times 4, 32, 64. 3 squared is 9, times 4 is 36. 2 squared is 4, times 4 is 16. And 1 times 1 is 1, times 4 is 4. And if you notice, the blue ones are all 1 less than the black ones. It means I have to add 1 every time. So my nth term is 4n squared plus 1. Therefore, my function is going to be f of x equals 4x squared plus 1. Pretty easy, huh? Now, the next one we're going to do is going to be a little bit more complicated, but not difficult. There's my sequence of numbers. I'm going to put it in my table, x and f of x. And we've got the first term, second term, third term, fourth term, fifth term. Looking for the nth term. We've got 9 and 29 and 61 and 105 and 161. All right, so go looking for the first differences. Plus 20, plus 22, 32, plus 32. Yeah, that makes more sense. Okay, and that one 40 would be 101, so this would be plus 44. And then this will be plus 56, I think. Yeah. All right, so the first differences don't match. Go looking for the second differences. It's plus 12, and plus 12. So they do match. So I'm going to have an n squared because the second differences match. And my coefficient on n squared is going to be half of the difference. So it's going to be a 6n squared. So I do my comparison line. And for this one, I'm going to do 6 times 1 squared. This one will be 6 times 2 squared, 6 times 3 squared, 6 times 4 squared, and 6 times 5 squared. All right, 5 squared is 25. 6 quarters would be 150. Okay, this would be 16. 16 times 6 is 96, I think. All right, let me just check that. 16 times 6, command and 6, carry 3, yeah, 96. All right, that's 9, and 6 times 6 is 54. That's 4 times 6 is 24, and then that will be 6. Now I'm going to erase this. Again, I don't want you to erase work, but just so it doesn't get too crazy. Okay, for the purpose of the video. This is kind of weird because it goes plus 3, plus 5, plus 7. It's not going up by the same amount every time. Plus, well, that's not plus 9, is it? Do I have a mistake? No, it is 9. Silly me. Yeah, that's 9. Okay, and then plus 11. All right, so I can't just do whatever I want. Here's what I'm going to do. I'm going to take these green numbers and I'm going to make a table out of those. Yeah, I'm going to make a second table. I'm going to go x and f of x. And I'm going to make the second table, the f of x numbers, these green numbers, 3 and 5 and 7 and 9 and 11. I'm going to go looking for the nth term, and this is the first one, the second one, the third one, the fourth one, and the fifth one. Now this 6n squared, it's not wrong, it's just part of my answer. The other part of my answer is going to come from this green table over here. So I'm going to go looking for the first differences, which are plus 2, plus 2, plus 2, and plus 2, right? So that means it's going to be something like 2n. It's going to be a linear pattern. So I do my comparison line, and of course I'm going to do 2 times 1, and 2 times 2, and 2 times 3, and 2 times 4, and 2 times 5. So that'll be 10, and 8, and 6, and 4, and 2. And how do I change the red one into the green one? Well, I add 1. 4 to 5, I have to add 1. 6 to 7, I have to add 1. That means my nth term is going to be 2n plus 1. So for this original one, it's going to be 6n squared plus the 2n plus the 1. So my function is going to be f of x equals 6x squared. Let me get rid of this scratch work here. Plus 2x plus 1. It's pretty easy to do. You just had to do 2 problems in one. The first part was discovering the quadratic part. And the second part was discovering the linear part of the function. Okay, it still is a quadratic function, but you had to do 2 tables. All right, let's do one more like that, and then we'll wrap up this video. So we've got our f of x, we've got our x, and we've got 1, 2, 3, 4, and 5. All right, we've got 6, 14, 28, 48, 74, and then n. Go looking for the first differences. It looks like plus 8, and that's going to be plus 14. It's going to be plus 20. That's going to be plus 26. Looks like the second differences are all plus 6. Okay, since the second differences are the same, it's going to be an n squared pattern. Since the second difference is plus 6, it'll be 3n squared. This is always half of the second difference. So I'll do my comparison line. And so 1 squared is 1 times 3 is 3. 2 squared is 4 times 3. 3 squared is 9 times 3 is 27. That's strange. I wonder if I have a mistake in this one. 4 squared is 16. 16 times 3 is 48, and then 75. This is kind of weird. I don't know. This is, I'm going to keep going. I don't think there's a mistake, but let's see what happens. All right. Now it looks like to turn the blue ones into the black ones, I have to add 3. But then I add 2, then I only add 1, and then I add 0, and then I have to subtract 1. Very interesting. Well, I'm going to take those green numbers. I'm going to make a table out of them. I'm going to see if I can figure out a pattern. Okay, f of x. And we got what? 1, 2, 3, 4, 5, and n. Okay. And so we're going to get 3 and 2 and 1. 0 and negative 1. And so now I'm going to go looking for my first differences. Well, it looks like it's going to be minus 1 and minus 1, minus 1, minus 1. This is going to be a linear pattern. It's going to be negative 1n. And so I'll do my comparison line. And 1 times negative 1 is negative 1. Negative 1 times 2, negative 2, negative 3, negative 4, negative 5. And so how do I turn these blue ones into the green ones? Now, you don't have to start at this one. You can start with the easiest one. I think the easiest one is this one. How do I turn negative 4 into 0? Well, I add 4. How do I turn negative 5 into negative 1? I add 4. Negative 3 into 1, I add 4. By the way, if you didn't know, you could take negative 3 plus x equals 1, and then you could solve for x. Need x equals 4. See that, the plus 4? So I'm going to add 4 every time. So this is going to be negative 1 and plus 4, and you can't really see that, negative 1 and plus 4. So my whole nth term is going to be 3n squared minus 1n plus 4. My function will be f of x equals 3x squared minus x, or minus 1x, plus 4. And there you go. Another one where you had to do a pattern within a pattern. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.